Tapi you need to submit it lah inside the Google Classroom as usual, right? So now moving on, we have another 4 example for me to show you. Okay, so please bear with me dan jangan ngantuk-ngantuk. Okay, so now, right, how to differentiate gx is equals to 3 secant x minus 10 cot x. Macam mana nak buat? Okay, this one bukan limit. Alright, so you can just straight away derive it or differentiate it. You can straight away differentiate it using the formula that I gave you in this page. Okay, if it is not enough, you can try to find it from textbook, from Google. You can use it. Okay, so now how to find the here is like this. Tengok senang je. Alright, just straight to the point. G prime x is equals to 3 secant x tangent x plus 10 cosine squared x. Okay, ni je jawapan dia. Macam mana saya dapat ni? Doktor, macam mana dapat ni? Tak ada masalah. Masuk je lah persamaan ni. Dapatlah. Okay. Secant x is equal to secant x tangent x. Cot x is equal to negative cosine squared x. So you just put your formula here to here. Then you can answer the question. Right? So for the second one, h omega is equals to 3 omega to the power of negative 4 minus omega squared tangent omega. Oh, so how to find this is, okay, yang depan tu senang je, negative 12 omega negative 5. Okay, minus yang belakang ni you kena buat a bit of product rule. Macam mana nak buat product rule? Come on student, saya dah ajar. Okay, equals to nanti you buat product rule. Okay, buat dah satu U, satu V. So you buat apa benda semua, you will get negative 2 omega tangent omega minus omega squared secant squared omega. Itulah jawapan dia. It's not that rocket science punya questions pun. It's not like kebat question. So kami berfikir aras tinggi punya question. It's just a question that you just put the formula and you'll be able to answer it. Right? Right? So again, for C and D, I will leave it to you to answer in online quiz. Okay. This one dengan soalan sebelah tu, you need to submit it tomorrow at 12. Okay, so jangan kata saya kejam sebab sebenarnya soalan ni sangat sikit. And then tomorrow kan from 9 to 10 you have this class, but I will do it asynchronously. However, because I want to give you time to do it self-study, review, watch some video, and at the same time you answer this question lah, so that tak ambil masa subjek lain to answer my questions. Alright, and then I bagi masa kecemasan until tomorrow at 12 o'clock. Okay, walaupun tomorrow will be a synchronous class, I will open Zoom for a few minutes or 1 hour for you guys to ask any questions, and also for you to scan the QR code for the class. Okay, but at the same time jangan tanya soalan yang saya bagi. Don't ask me the question that I ask you to answer. Okay, ask any other question and can, but not the question that I want you to answer. Alright, moving on, next is the derivative of exponential function. Okay, so what if x is equals to a to the power of x? Okay, so here is, right, okay, so here is ni adalah how it comes to find the answer for the derivatives of exponential function. Okay, if you need to understand again or clearly, whenever the question is find the derivatives of something something, you need to come to this basic equation, which is the derivatives or the f prime x or the dfx over dx is equals to limit h approaching 0, fx plus h minus fx over h. Okay, how to come to this equation is from our last chapter, chapter 2, from limit. Okay, from limit, right? Tu dia punya asal usul dia. Okay, so then after that, we use this all the way in our derivative class to find the answer for each function. Okay, so here we want to find ax, right? So we just put limit h approaching 0, ax to the power of h minus ax over h. Then you'll get to this, and then you'll get to this, right? So now, dia dah asingkan, you apa ni, asingkan dia. Now the a to the power of x is not affected by the limit since it doesn't have any h in it. And so is a constant as far as the limit is concerned. We can therefore factor this out of the limit. This gives f to the power of x equals to ax limit h approaching 0, a to the power h over h. Alright, now let's notice that the limit we've got above is exactly the definition of the derivative of fx is equals to ax. Therefore, the derivative of f prime x is equals to f prime 0 ax. Okay, so that's why hence the limit for a to the power of x is always a to the power of x. Okay, so now student, we have only 2 minutes left. I will stop this Zoom and please come again to my class as soon as possible, right? Using the same link. Okay. Discuss. Okay, so see you soon, student. So I'll share with you sharing. Now I will share with you sambungan tadi. Derivatives of the exponential function. Okay. Right. Okay. So a to the power of x, fx, fx is equals to a to the power of x. So f prime x is equals to f prime 0 times dengan ax. Alright. So derivatives of exponential function for epsilon. Alright. Some definition of e. E is equals to limit n approaching infinity 1 plus 1 over n to the power of n. Okay, student? Right. So now, E is the unique positive number for which limit h approaching 0, e to the power of h minus over h minus 1 over h is equals to 1. So E equals to the sum of n equals to 0 to the infinity 1 over n, right? So in this case, fx is equals to e to the power of x is always f prime x is equals to a to the power of x. And if fx is equals to a to the power of x, tadi e, now a, okay? Given that a is equals to constant, f prime x is equals to ax, a to the power of x ln a. Right? So for the natural exponential function, fx is equals to e to the power of x, we have f prime 0 is always equals to 1. So kalau awak ingat from the previous slides, okay, f prime x for the function of a to the power of x, dia ada kat depan tu f prime 0, right? So in case of natural exponential or epsilon, e here is always 1. Hence, it's always e to the power of x again. Alright? Dia macam repeating. You derive it many times, it come to e to the power of x again. Right? So now dx over dx is equals to e to the power of x. D ln x over dx is equals to 1 over x. D a to the power of x over dx is equals to a to the power of x times ln a. And d log ax over dx is equals to 1 over x ln a. Sebab log nanti we can have any log 2, log 3, log 4, log 5. So log 5x, for example, so you need to, the answer will be x ln 5. If the question is like that. Okay, so now moving on, property, this is some of the properties of the natural algorithm, right? But I want you guys to kalau kita nak tekan kat sini macam mana? Okay, tak boleh nak tekan. Okay, so sebab saya ada 10 minutes.
Welcome to a video on the derivative
please
of an
watch this
exponential
student,
function.
okay?
The
Nampak
goal
ni
of
kan?
this video is to differentiate exponential functions. Let's go and take a look at the rules. If our base is e,
Sorry ya, internet saya ni jadi macam ni pula lepas tak ada elektrik tadi. Tapi bear with me.
welcome to a video on the derivative of an exponential function. The goal of this video is to differentiate exponential functions. Let's go and take a look at the rules. If our base is e, the derivative of e to the x is equal to e to the x. This is actually quite amazing. This function is its own derivative, meaning if we evaluate the function at a given value of x, the function value also tells us the slope of the tangent line at that x value. The second formula here just applies the chain rule. If the exponent is some function in terms of x, we'd apply the chain rule, and the derivative would be e to the u times a u prime. Now, if the base of the exponential is not e, then notice the derivative would have an extra factor of natural log a times a to the x. And then again, this last rule is if we have a raised to some function in terms of x, we would have to apply the chain rule. So we have natural log a to the u times u prime. Let's take a quick look at a rough proof of the derivative of the function f of x is equal to e to the x. We start with the basic exponential function, apply the limit definition of derivative, do our substitution, do some fancy algebra here, factor out a to the x. And what we have is a to the x times this special limit. And what we're going to argue now is if we knew the value of a that would make this limit equal to 1, then we would have the case where the exponential function is its own derivative. And so what we do is we take that special case over here. What would a have to be in order for this limit to equal 1? Well, if we assume it's equal to 1, solve it for a to the h, and raise both sides of the equation to the power of 1 over h, we'd have a equal to this expression here, which we could then conclude that if this limit is equal to 1, then a would be equal to this limit here. And by definition, this limit is equal to e, therefore we have a equal to e. So when a is equal to e, going back over to the left side, we have the derivative of e to the x is equal to e to the x. Now you may want to pause and take a closer look at this proof, but that's the general idea. Now the next case is what do we do if the base isn't e? Well, from some of our properties, we can rewrite a to the x as e to the power of x times natural log a. And in this form, we can just apply the chain rule to the derivative of e to the u. So what we're saying here is that the derivative of a to the x is equal to this derivative. So if we let this equal e to the u, the derivative of this function would be e to the u times u prime. Now natural log a is just a constant, so the derivative of u is just 1 natural log a, which gives us natural log a times a to the x when a does not equal e. Again, you may want to pause the video to take a closer look at this, but that's the general idea. Let's go ahead and put it into practice. Let's say we want to find the derivative of each of these functions. So for the derivative of this function, so to find the derivative of this function, we are going to need this derivative formula, e to the u times u prime, where our value of u is equal to 6x. So first we have the derivative of this term, which would be 10x to the 4th minus 3 times, here's our formula, e to the u times u prime. That would be e to the power of 6x times u prime, the derivative of 6x would be 6. We can clean this up to 10x to the 4 minus 18e to the power of 6x. Now, number 2, we have to realize that this is a product of two functions. We'll call the first function f and the second function g. So we're going to have to apply the product rule. And so what I've done already is set this up. We have the first function times the derivative of the second plus the second times the derivative of the first. Let's go ahead and find these derivatives and then simplify. Now the derivative of e to the power of negative 2x, we are going to have to apply the chain rule again. So our derivative is e to the u times u prime. So we'd have e to the power of negative 2x times negative 2 plus e to the negative 2x times the derivative of x to the third, that would be 3x squared. We have negative 2x cubed e to the negative 2x plus 3x squared e to the negative 2x. Now I will factor this one. We can see these two terms have a common factor of x squared e to the negative 2x. Now if we factor this out of the first term, we'd be left with negative 2x. If we factored x squared e to the negative 2x out of this term, we'd have a positive 3. So I'll put the positive 3 first and the minus 2x second. And now there's a derivative in factored form. Let's go ahead and try another. Here we have a quotient. So on the right side here, I wrote out the quotient rule. Remember, it's low d high minus high d low, low, low. And over here on the left, I've already set it up. We have the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. The derivative of e to the power of 3x would be e to the 3x times u prime, so there are 3, minus e to the 3x times 6x to the 5th, all over x to the 12. Let's clean this up and then see if we can factor it. Now I notice the numerator has a common factor of 3x to the 5th e to the 3x. Let's factor that out. So we'd be left with x minus 2 over x to the 12. And we can see that we have an x to the 5th here and an x to the 12th here. This would simplify and this would become x to the 7th. So our final derivative would look like this. Okay, let's try another question. Determine the slope of a tangent line to the function at the given point. Well, we know in order to find the slope of the tangent line, we have to find the derivative of this function. Let's go ahead and do that. It would be 2 times the derivative of e to the power of 3x. Again, hopefully we're pretty good now recognizing that our u would equal negative 3x. So we're going to have e to the u, e to the negative 3x times a negative 3. So our derivative function is negative 6 e to the negative 3x. If we want to find the slope of the tangent line at this point, we need to evaluate this function at x equals 0. Of course, e to the 0 would be 1. Negative 6 times 1 gives us a slope of negative 6. Let's go ahead and graph this function and check our work. So here's our function, here's our point of tangency. The question is, does this line have a slope of negative 6? If we start up here and go down 6 units and write 1, we have the correct line, which verifies our work. Let's go ahead and take a look at one more application question. More Americans are buying organic fruit and vegetables made with organic ingredients. The amount, A of t, in billions of dollars spent on organic food t years after 1995 can be approximated by this function. We have 2 questions to consider. Estimate the amounts that Americans will spend on organic food in the year 2009. So the question is, what value of t are we going to use? Well, based upon the question, 1995 was our base year. So we have to take our desired year and subtract 1995. This will give us 14. So this is not a calculus question. We just need to evaluate A at a value of 14 for t. Second natural log brings up the base E. We have approximately 30.2. Now, if you recall from the question, it was $30.2 billion. A of t was in billions. And the last question, estimate the rate at which the spending on organic food was growing in the year 2006. Whenever we hear that word rate or rate of change, we should be thinking derivative. So we need to evaluate the derivative. Let's start by finding our value of t. That's going to give us a t value of 11 for this question. But on this one, we want to find the rate of change. We need to find the derivative. Remember, the derivative of this would be e to the u times u prime. Of course, t prime, of course, u prime would be 0.18. So simplifying this, we would obtain the derivative function here. So if we simplify this, we'd obtain this derivative function. And now we need to evaluate this at t equals 11. Which gives us approximately 3.17. Again, this is in billions of dollars, but it's a rate. So billions of dollars, and time is in years, so per year. At that instant where t is equal to 11. Now I'm going to go back to the graphing calculator just for a moment and show you another way you can check your work. This graphing calculator will evaluate derivatives at a specific value of x, or in this case t. So if we hit our math key and scroll down to option 8, if we type in the original function, now I'm going to use x instead of t, then type in comma x, comma the value of x we want to determine the derivative at, which is 11, it will give us the same answer. It's a nice way to check, but I'm sure your instructor will want you to show the derivative function. Okay, I hope that helps explain how to find the derivative of exponential functions. Thank you for watching.
Okay, student. Harap you...
In this video, we're going to focus on derivatives.
Right? Sebenarnya link tu link yang sama je. Mungkin Farhana kena tengok dia ada problem dengan connection dia. Tak stabil ke apa Try to have a look lah.
Doktor, thank you.
Ya, sama-sama.
Maaf ganggu.
Tak apa. Okay. Nanti awak ni lah catch up lah balik Alright. So now kita akan tengok for the properties of the natural algorithm. Alright. The domain, okay, in this case, the domain, the first one, domain and range of ln x are 0, infinity, and negative infinity to infinity, respectively. And then the second one, ln xy is equals to ln x plus ln y, for x and y is greater than 0. Okay, so for this properties you should be familiar with. It's just for you to revise only. And for ln x over y is equals to ln x minus y. Ln x minus ln y. And the same as for x and y is greater than 0. Okay, ni semuanya benda yang you dah belajar and is at least as a revision for you. Ln x to the power of p is equals to p ln x. Okay, for x is greater than 0 and p is a rational number. So I really hope that this one is not new properties for you. Okay, this is just a recap. Number 5, d ln x over dx is equals to 1 over x. And then for x must not equal to 0. And d ln ux is equals to u prime x over ux. Right? For ux tak boleh sama dengan kosong. Okay? Whatever things that have over x here, x tak boleh sama dengan kosong. If x sama dengan kosong, it will become infinity, which is the function will not behave, will not be behaving well. Right? So now, derivative of log bx, right? If b is greater than 0, with b not equals to 1, then log bx is equals to 1 over x ln b for x is greater than 0. Then d log bx over dx is equals to 1 over x ln b. Okay, for x must not equals to 0. Derivative of b to the power of x is equals to bx times ln b. right? Derivatives and integral of the exponential function for real x. For example, d e to the power of ux is equals to e to the power of ux u prime x. Okay, and the integration of e to the power of s ds is equals to a ex plus c. Okay, ni semuanya sebenarnya recap saja from things that you have learned before. Okay, there's one YouTube that we can watch together, but kejap boleh ke saya tengok? Boleh lah, kita tengok sekejap lah YouTube ni satu lagi But student jangan tidur tau. Tolong tengok YouTube yang saya nak suruh you all tengok ni. Okay.
In this video, we're going to focus on finding the derivative of a logarithmic function. But let's start with natural log functions first. So what is the derivative of ln x? Now there's a formula that you need to know. The derivative of ln u is equal to u prime divided by u. So in this example, u is x, and the derivative of x is 1. So therefore, the derivative of natural log of x, that's going to be 1, is x squared, and derivative of u, or u prime, that's going to be 2x. So we can simplify this. X squared is basically x times x. So we can cancel an x, and so the final answer is 2 over x. Now, what you could do also is you could move the 2 to the front before you find the derivative of the function. So ln x squared is the same as 2 ln x. And that's going to be 3 times the derivative of ln x. And the derivative of ln x is 1 over x. So this is just going to be 3 divided by x. Here's another example. Find the derivative of the natural log of x plus 5. So let's use the formula. U is x plus 5. U prime, the derivative of x4. So in this example, u is x squared plus 4. And the derivative of x squared plus 4 is 2x. So using the formula u prime divided by u, it's going to be 2x divided by x squared plus 4. So it's basically the derivative of the function on the inside divided by the original function. Go ahead and try this problem. Differentiate the natural log of 7x plus 5 minus x cubed. Now let's differentiate the inside function. The derivative of 7x is 7. The derivative of a constant is 0. And the derivative of negative x cubed is negative 3x squared, divided by the original stuff on the inside, which is 7x plus 5 minus x cubed. So that's going to be the answer for this example. Now let's try some harder problems. Go ahead and find the derivative of the natural log of sine x. So in this example, u is equal to sine x. U prime, the derivative of sine, that's going to be cosine. So it's going to be u prime over u, so cosine divided by sine. And what trig function represents cosine divided by sine? Cosine over sine is cotangent. So the natural log of sine x is equivalent to cotangent x. That is the derivative of the natural log of sine x. Now go ahead and differentiate the natural log of the 7th root of x. Try that problem. Now the best thing to do for this example is to rewrite it. So let's rewrite the radical as a rational exponent. So this is going to be x raised to the 1 over 7. And then we can take the exponent and move it to the front. So this is 1 over 7 times the derivative of the natural log of x. So this is going to be 1 over 7 times 1 over x. So the final answer is 1 over 7x. Here's another problem that you can work on. go ahead and find the derivative of the cube root of ln x. Once again, I suggest rewriting the expression into a form that's easier to deal with. So the cube root of ln x, that's basically ln x raised to the 1/3. Now this time, the 1/3 applies not only to the x, but the entire ln x expression. So you can't just move it to the front. What we need to do is apply the chain rule. And let's say if you want to differentiate a composite function, f of g of x, you need to differentiate the outside part of the function, keeping the inside the same, and then multiply by the derivative of the inside. So that's the basic idea behind the chain rule. So to use that, let's use the power rule. So let's focus on the outside part of the function. Let's keep the natural log, the inside part, g of x, the same. So using the power rule, this will go to the front. So it's going to be 1/3, and then we need to subtract the exponent by 1, times the derivative of the inside, which is g prime. The derivative of ln x is 1 over x. Now 1/3 minus 1, that's the same as 1 over 3 minus 3 over 3, and that's negative 2 over 3. So we have 1/3 ln x to the negative 2/3 times 1 over x. Now, there's going to be a 1 in the numerator. We have a 3 and an x in the bottom, so I'm going to write that as 3x. Now, ln x will have a negative exponent if it's placed in the numerator, but if we place it in the denominator, it's going to have a positive exponent. And so we can rewrite the final answer as 1 over 3x times the cube root of ln x squared. And so that's it. Now let's go over the derivative of regular logarithmic functions. So what is the derivative of log base 3 of x? Now here's the formula. The derivative of log base a of u is equal to u prime divided by u times ln a. In the case of the natural log, which has the base e, this is going to be u prime over u ln e. But ln e is 1, so it simply becomes u prime over u. But if you have a base that's not e, then you need to have ln a. Other than that, everything else is the same. So in this example, u is equal to x. So the derivative of x is 1, and a is the base, that's 3. So the answer is going to be u prime divided by u, which is x, times ln a, or ln 3. So it's 1 over x ln 3. Here's another example that you can work on. Differentiate log base 4 of x squared. Now we can move the 2 in the front if we want to.
2.
So this is going to be 2 times log base 4 of x. So it's going to be u prime,
2.
that's the derivative of x, divided by u, which is x, times ln a, and there's a 2 in front, so times 2. So the final answer is going to be 2
2 over
x natural log of 4. Try this one. Log base 7 of 5 minus 2x. So u is 5 minus 2x. U prime, that's going to be negative 2, and a is 7. So the formula, it's u prime over u ln a. So u prime is negative 2, and then u is 5 minus 2x times the natural log of the base. So the natural log of 7. And that's it for that example. Now, what is the derivative of log base 2 3x minus x to the 4th? So go ahead and try that. So u is going to be 3x minus x to the 4th power. U prime, the derivative of 3x is 3, and the derivative of x to the 4th is 4x cubed. And a is the base, that's 2. So using the formula u prime divided by u times ln a, or ln 2. So all you need to do is identify u prime, and a, and you'll get the answer.
Nah, just do that.
Let's work on one more example with logs. So go ahead and find the derivative of log base 5 of tangent x. So u is tangent. U prime, the derivative of tangent is secant squared. And a is 5. So using the formula u prime over u ln a, it's going to be secant squared divided by tangent x times the natural log of 5. And that's it. Now going back to natural logs, there's one more example I want to cover. What is the derivative of the natural log of ln x? So we have a natural log inside a natural log. How can we differentiate this function? So let's focus on the main one. Keep in mind the derivative of ln u is u prime over u. So notice that u in this example is ln x. So if u is ln x, what's u prime? Now you know that the derivative of ln x is 1 over x. So the answer is going to be u prime, which is 1 over x, times u, which is ln x. So let's multiply the top and bottom by x. 1 over x times x is 1. So it's 1 over x ln x. And that's the answer.
Okay.